find the equilibrium point, and always remember the equilibrium point has an x and a y. If you just determine x, that's not good enough. For the equilibrium point, we have to determine x and y. We set the functions.
Is it the dx and sx?
The demand function and the supply functions.
Equal to each other?
Excellent. Equal to each other. Perfect. Awesome. Thank you. To find the consumer surplus, the area of the from this. The area of the
subtract.
Very good. The area of the
square.
Yes, it's a rectangle. It can be a square, of course, but it's most probably a rectangle. Good. The area of the rectangle from, I'll help, from, since it's the consumer, so it's the demand dx. Perfect. So exactly what we just said here. I put it in words for you. Right? So we subtract the area of the rectangle from the integral from 0 to, or a to b, 0 to whatever, from d of x dx. Awesome. Great job. Finally, to find the producer surplus, we, from the area of the v.
Subtract?
Yes. Subtract from the
area of the rectangle.
Yes. The integral from a to b from
dx of dx.
S of x dx. Perfect. So now we know we established these two. Of course, most probably this will be from 0 to a number, whatever that is. Okay, perfect. So any questions from me now? Any questions?
I actually have one question from my math lab.
Yes, I'm ready.
Can I share my screen?
Oh, of course. Please do. Did it give you permission?
Yeah.
Perfect. Okay. So suppose the temperature in degrees Celsius over a 9-hour period is given by, so we have T of T, negative T squared plus 8T plus 37. Please confirm that I see that correctly. Negative T squared plus 8T plus 37.
Yes.
Find the average temperature. Okay, it says on a 9-hour period. So I'm assuming 0 to 9. Find the minimum temperature. Okay, and then find the maximum temperature. Perfect. So you can stop sharing now. Very good. Awesome. So the first we're asked to find the average. How do we find the average temperature on a 9? I'm assuming it's 0 to 9. So part A.
T minus 9.
So the formula is F average on A comma B equals 1 over B minus A, the integral from A to B, from f of x dx, or f of t dt, doesn't matter. So this is the average on a given interval. Good. So let's calculate that. So F average, in this case, is for T of T average is 1 over 9 minus 0, the integral from 0 to 9, negative t squared plus 8t plus 37 dt. Is this okay? Do we need to continue, or can you finish that up, or you want me to, or?
Can you continue?
Yes. So then we have 1 over 9, and this is negative t to the third over 3 plus 8t squared over 2 plus 37t from 0 to 9. There is no point in plugging 0. It's a polynomial. This doesn't always happen, but it's a polynomial, so I'm not going to plug in 0. So I have 1 over 9, negative 9 cubed over 3 plus 4 times 36 plus 37 times 9. Good. So I'm going to share my screen real quick. And I don't understand what this is all about. I needed this. Okay, so I have 1 over 9 in front, and open a parenthesis, and we have negative 9 to the third, and divide that by 3, and then plus 4 times 36, and then plus 37 times 9. So the average is 26. And I think they said 26 in degrees Celsius. Okay, how do we determine for part B and part C, how do we find the min or max of this function? T of t, negative t squared plus 8t plus 37 on the given interval 0, 9. Anyone remembers how to proceed?
Is this when we make the chart and we find that?
Exactly. Yes. Thank you so much. So we have to find t prime. Excellent. Only between 0 and 9. So t prime is negative 2t plus 8. Of course, we have to set it equal to 0. It's never undefined because we need to find the critical numbers. So this would be t equals 4. When we plug in 0, we get positive. When we plug in 5, we get negative. So at this point, if you remember, on a closed interval, we have to put the function in and determine these values. And then we will determine max and min. So I'll put it in y equals, and the function was negative t squared and plus 8t, and then plus 37. And then I go to, of course, I plug in 0, I plug in 4, and I plug in 9, and I get 37, and then 53, and then 28. So obviously, this is increasing, and this is decreasing. So we're asked to find the minimum and the maximum. Can anyone give us the minimum and the maximum for this function?
The minimum is 28, the maximum is 53.
Very good. So the point is 4, 53, but this is the actual maximum. But the point is 4, 53. The point is 9, 28, but this 28 is the actual minimum. And this is nothing. Very good. Is this okay?
Yes.
Perfect. Other questions for me? Anything else? Did you work on anything else? Do you need help with anything else?
I sent a problem in the chat. Can you?
Oh, yeah, I didn't see it. Sorry. Okay, so what do I do with this? So I think it's 5x squared.
No, it's
X plus.
X squared. That's not it. That's not 5. That's what do you call it?
The integral. Oh, okay.
Yes, yes.
So the integral of x squared, x plus 4 squared dx.
Yeah.
Perfect.
No
Okay.
5.
Is that okay?
Yeah.
Did I copy it correctly? Okay, perfect. Okay, so in this particular case, I would not do anything but just expand. Because this is, if this is 12 or 20, of course, that would be terrible. But in this case, I would just expand it. So this is x squared, and this is x squared plus 8x plus 16 dx, and then distribute. X to the 4th, 8x cubed plus 16x squared dx. Okay, so then this is x to the 5th over 5 plus 8x to the 4th over 4 plus 16 x to the 3rd over 3 plus a constant c. And I will just simplify these two.
Okay, that's good enough. Thank you.
Yeah, sure. Perfect. Other questions? Anything else we need to go back to? Anything? Anyone? Anyone else? Okay, so we're trying to finish chapter 5 today, and we continue with 5.7. 5.7 deals with differential equations. And the specific one type called separable differential equations. But we'll get to that in a moment. So now let's discuss what a differential equation is. So a differential equation is an equation that has derivatives in it. Something like the second derivative plus 2, the first derivative equals 2y plus x cubed. This is an example of a differential equation. So you see this equation has the function, but also has its derivative, first derivative, and it also has its second derivative, right? So something like this. We're going to start slowly. Oh, now I see what that was telling me, that I was logged out. Ah, that's what the problem is. So I have to log myself back in to open the book. So sorry. And as you know, they have to authenticate me. I don't know how this works for you, but I have to look for my phone. I have to log in. I have to let them call me. So sorry, I was idle for a while, I guess. Okay. Yes, please call. Okay, I think I'm authenticated now. Oh, yes, I'm in. Okay. So where is it? I want to go to Canvas. Okay, I'm going to go to my course. I want to go to my lab. And this is chapter 5 and section 5.7. I want this. Okay. I want chapter 5. I want 5.7. Only the book. That's good enough. Okay, finally. So we are on page 535. Good. So first of all, we are in the first set of problems. We are given a differential equation. And they're asking us to find the general solution and the particular solution for the given initial condition. So all these examples are exactly the same we did in chapter 4. So this first initial warm-up for differential equations is just what we already know. So please choose anything you like from 1 through 6. This is the simple one.
Could we do 5?
Yes, let's start with number 5. Perfect. 5 on page 535. And we have y prime equals 3 over x plus x squared minus x to the 4th. And they are given as the initial condition that y is, when x is 1, y is negative 4. Make sure I copied correctly. Yes, 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 yes. Perfect. So in order to solve this differential equation, this is not a complicated situation. All we have to do is just integrate this. We're asked to find y. So what function prime is 3 over x? What function prime is x squared? What function prime is negative x to the 4th? And of course, plus a constant c. Nothing different from chapter 4 when we were finding antiderivatives. I'm given the derivative. I want to find antiderivative. So, which function prime is 3 over x?
Is it 3 ln of x?
Yes. Don't forget the absolute value. Always. Perfect. Plus, which function prime is x squared?
X cubed over 3.
Perfect. And minus.
And then x to the 5th over 5.
Perfect. So this is good, but it's not good enough because they are asking us, or they're giving us, or they're asking us to find y, the unique y. They're telling us that when x is 1, y equals negative 4. Y is negative 4 when x is 1. No problem. Negative 4 equals, how much is natural log 1?
Zero.
Perfect. So this is 0. 1 here is 1/3. 1 here is negative 1/5, and plus a constant c. So this condition, initial condition, is given to us to determine c. So I will move these two to the other side. So c equals negative 4 minus 1/3 and plus 1/5. Yes, if you have any difficulties with this, you can use the calculator, but the answer has to be as a exact, as a fraction, in a fraction form. So the least common denominator is 15. This one needs a 15, this a 5, and this a 3. So negative 60 minus 5 and plus 3. Okay? So c equals negative 65 plus 3, negative 62 over 15. Now I have to write y one more time, and this is it. So the first set is just a warm-up, basically what we studied in chapter 4. Any questions on this?